Hello everybody, so for this video, I'm going to be teaching you about the intermediate value theorem. So this is the definition of it. It is, suppose that f is continuous on the closed interval a comma b, and let n be any number between f of a and f of b, where f of a does not equal to f of b. Then there exists a number c in a comma b such that f of c is equal to n. So I drew like a little graph here just to show what that looks like. So let's just say we have our line y is equal to n, and we have our function right here. And we have 2 points, f of a and f of b. So you can see that f of a and f of b, there's y is equal to n, which is in between, which means that there's a number c anywhere on this graph, which is actually this point right here, because it's on y is equal to n and it's on the graph. So that means this point right here would be c comma n. So that's just basically the intermediate value theorem. It's mainly used just to find roots of functions in between in a given interval. Let's work on the first example. Okay, so right here we have show that there's a root of the equation 4x to the power of 3 minus 6x squared plus 3x minus 2 is equal to 0 in the interval 1 comma 2. Okay, so first what we need to do is find, let's say this is equal to f of x. So we need to find f of 1. So to find that, we can just plug in 1 into every x value. So here we'll have 4 minus 6 plus 3 minus 2. Oh yeah, and just so you know, when it says root here, that means our n is equal to 0. So now we're trying to find c, which is our root. So if we just evaluate this, we'll see that we have minus 2 plus 1, which is equal to negative 1. Okay, and then now we have to plug in 2 for x. So we'll have 32 minus 24 plus 6 minus 2. We will have 8 plus 4, which is equal to 12. So you can see how f of 1 is less than 0 and f of 2 is greater than 0. And this f of 1 is our f of a, and this f of 2 is our f of b. And now you can see that these two values are actually in between, or 0 is actually in between these values. And since this function is continuous, there's no holes or asymptotes or anything, that means that there is a value c in between, or there's a value c which will be our root. Okay, so let's move on to the next one, and this one I want you to try on your own. So show that there's a root of the equation 2x to the power of 3 plus x squared plus 2 is equal to 0 in the interval negative 2 comma negative 1. Okay, so let's do what we did before. So let's plug in 2 for every x value, because we need to find f of negative 2. Okay, so 2 times negative 8 plus negative 2 squared plus 2 is equal to 0. Okay, so now let's just evaluate this. We have negative 16 plus 4 plus 2, which is equal to negative 10. And then we have negative 1. So let's just plug that in. We'll have negative 2 plus 1 plus 2, which is equal to 1. And you can see how this is less than 0 and this is greater than 0, which means there's a number c where the y value is equal to n, which is our 0. So that means there is a root in this equation. Okay, so thank you for watching, and I hope you learned something today.